Hello there, welcome to this video. We're going to continue talking about average value of a function for AP Calculus. This is lesson 1, 8-1 of the final unit, applications of integration. We're going to go ahead and look at some FRQ applications, and we'll look at some past FRQ questions about how the average value questions pop up on the exam. Alright, so let's get to a couple of contextual examples. Here, example 6. This is the first question on the 2022 exam. They say from 5 a.m. to 10 a.m. the rate at which vehicles arrive at a certain toll plaza is given by A of t, where t is the number of hours after 5 a.m. and A of t is measured in vehicles per hour. They say traffic is flowing smoothly at 5 a.m. with no vehicles waiting in line. A. Write, but do not evaluate an integral expression that gives the total number of vehicles that arrive at a toll plaza from 6 a.m. to 10 a.m. and they're kind. They give us the t values here. So a couple of things. First, they just want us to write, and it's important. They say do not evaluate. Do not be a hero. You don't get any extra points. You're just more likely to screw something up. Just write an integral expression. So all we're going to do here is write for part A, an integral expression. They want the total number of vehicles that arrive. So I'm going to use this function here, A of t, that's the vehicles arriving, dt. If you want to write the function 450 square root of sine instead of A of t, you can do that, but A of t is pretty simple. I'm going to write that. I also need bounds on an integral expression, and they tell us here from 1 to 5. From 1 to 5. That's it. Easy points. Take those easy points. That's part A. Part B, they say find the average value of the rate in vehicles per hour at which vehicles arrive at the toll plaza from 6 a.m. to 10 a.m. So this one's kind of a continuation of the last question. We're going to take our total number of vehicles found by taking the rate and multiplying it times an infinitesimally small slice, small width. Okay, this would give us a total number, but this is an area. Remember, an integral is an area, and we want the average value of the rate. So to get back to a rate, I have to divide by those x values, or those t values. And remember, this is done by dividing by the difference in your bounds. So we're going from 1 to 5, so I'm going to divide by 1 divided by 5 minus 1. So this is 1/4. 1/4 of the integral from 1 to 5 of A of t dt. And we're going to use our calculator to go ahead and do this. So if you have your calculator, go ahead, take it out. I'm on a calculator tab here, and we're going to use this button right next to the book. Has all these mathematical functions. So we're going to do the integral from 1 to 5 of A of t. So I'm going to enter that now. 450 times the square root of sine of 0.62 t. If I use t here, I have to match my differential dt. You might get an error if you use a different variable. If you use like an x here and a t here, make sure your your variables match. That's the most important thing, okay? So note that this is the integral. I have the average value, so I have to have a 1/4 here. I'm just going to go back and I'm going to add the 1/4. I want 1/4 of this. You could take all this and divide by 1/4. It's going to give us the same thing. And so we get a value that is 375.537. Okay. All right, moving on. 2019, the first question. This is example 7. Fish are entering a lake at a rate modeled by the function E of t. Fish leave at a rate modeled by the function L of t. Both E of t and L of t are measured in fish per hour, and t is measured in hours since midnight. It's important to note, when they give you these units, you can easily tell these are derivatives. They're giving you the first derivative. I have fish entering, fish leaving, and their rates. So they say how many fish enter the lake over the 5-hour period from 0 to 5 a.m. from midnight to 5 a.m. So that's 0 to 5. So what we're going to do is we're going to go ahead and we're going to integrate that rate. We're going to accumulate the total amount of fish. So A, I'm going to go ahead and integrate from 0 to 5, and the function I'm using is e of t dt. Now, I'm not using L of t because I don't care about the fish leaving. I just want e of t. Okay, so let's go ahead. Let's use our calculator, and we get an integral from 0 to 5 of e of t. And e of t is 20 plus 15 times sine of pi. I'll use a different variable. I'll use x now just to highlight the x dx. Gives me a fraction. Let's see if control enter will hand me out. Okay, so this is 153.458. So this is my answer with 3 decimal places. Now, note they say here, round to the nearest whole number. Give your answer to the nearest whole number. So I'm going to write right below it 153 fish. That's how many fish are entering the lake. All right, part B. Here's the average value question. What is the average number of fish that leave the lake per hour over the 5-hour period from, again, 0 to 5? So this one, same structure, except over 0 to 5. Again, I have 1 minus 5 minus 0, right? So this is my average. I'm dividing by the width of the time period that's in question, right? B minus A, 5, minus 0, 5, 1/5, times the integral from 0 to 5, and I want the average number of fish that are leaving the lake. Leaving. So I'm going to use L of t dt. So always write down what you're putting into your calculator. You must document what you're putting down. And I'm going to go ahead and bring up my calculator. Okay, and so I have 1/5 times the integral from 0 to 5 of L of t. And L of t, if I look this up, 4 plus 2 to the power. 0.1, I'll go back to t squared dt. Enter. And so we get 6.059. 6.059. And this is fish per hour. They don't ask me to round to the nearest whole number, so I'm leaving it. I'm leaving it as 3 decimal places. You guys, that's it. That's average value in context. You just take an integral and you divide by the difference in the bounds. Catch you in the next video. Stay cool. See ya.